Hi, everyone. Welcome back. We're continuing on with our lecture regarding endocrine system. Here's where we left off. We were discussing the pituitary gland. I like to call the pituitary gland like the master gland. It essentially is responsible for the activation of a bunch of different glands in the endocrine system, and thus allowing the rest of the endocrine system to do its job. Um, Sorry, just starting a timer to make sure we're good pace for today. Okay. Um, the last thing I mentioned is that this tiny, tiny pea-shaped gland, so very, very small, found under the hypothalamus, as we can see here, it's going to cascade these hormones, thus activating different glands, like I just mentioned, thyroid, adrenal cortex, gonads, for instance. Um, we did talk a little bit about the hypothalamus. It's a part of the brain that we mentioned in nervous system part 2 that is going to be more responsible for activating the endocrine system. But for now, that's as far as we need to worry. All right, let's actually shrink that a little bit. There we go. All right, let's move on down. Okay, so the thyroid. The thyroid gland, it is a gland found in the neck region, so it's generally pretty easy to feel. It's right around your Adam's apple area. So it's found on the interior side of the trachea, so the front side. It's found right where the windpipe would be, as we call it, just inferior to the larynx, so it's a little bit below your vocal cords. Two lateral lobes and an isthmus. We don't have to worry too much about that. That's a little bit more detailed. But an isthmus is what you'd see here. It's this little bridge. That's a fancy name for a bridge that connects the two regions. Produces two hormones. This is stuff that we definitely need to know. So I'm going to go ahead and just circle some stuff for us. So the hormones it secretes, we do need to be aware of this. We have our thyroid hormones. Now, the thyroid hormones can be summarized into T4 and T3, also known as tyrosine and thyroxine. We'll talk a little bit more about those in the coming slides. And then the other major hormone is called calcitonin. Calcitonin, just to go back to some of the stuff we covered on day one, calcitonin is one of the major hormones that we're going to learn with regards to our feedback loops. Specifically, there's a feedback loop called the negative feedback loop. There's another one called positive feedback, and we'll get into what each is as we progress through this unit, but that's something that definitely we need to spend some time with. Now, just looking at calcitonin, we do see a little bit of information that we're able to grasp. First of all, calcitonin involved with calcium and phosphorus metabolism. Well, the phosphorus stuff, okay, that seems a little bit more out of the norm, but the name calcitonin, if you look at the prefix, calc is telling us that it's associated with calcium. So that makes sense to us, right? So calcitonin is involved with your normal levels of calcium in the body. All right, so let's scroll down. Again, a lot of this here we don't need to worry too much about, but this is just showing us some of the anatomy of what's going on in the neck region, or the cervical region, as we like to call it. Okay. The thyroid is composed of spherical follicles. We don't have to worry too much about this. These are the type of cells. So this is, again, a little bit further than we may need, but these are the specific cells in the thyroid that create the stuff that we care about. So for instance, we have these follicle cells, very, very tiny, that we see in between these regions. These follicle cells are going to produce thyroglobulin. This is the precursor to inevitably what we call thyroxine. That is important, that we'll get to a little bit more. The colloid lumen, and that's just the tissue of the thyroid. Don't have to worry too much about that. And then there's also what's called these parafollicular C cells. Those C cells, as you can imagine, help with calcitonin. Do we need to know that for testing? No. More so than anything, the name of the hormone. I kind of mentioned this in our second video relating to endocrine system. The big things that we need to know for this system are the tissues, or the glands that secrete hormones. On top of that, the hormone that it secretes, and what do those hormones do. Those three things are really what we want to be focusing on for this unit. All right, let's go down. Okay, now we're getting into feedback. As far as feedback is concerned, the idea here is how it relates to itself. Positive and negative feedback, the whole purpose is to achieve homeostasis. Homeostasis, as we remember, is just internal body balance. So homeostasis, for instance, could be body temperature. 98.6 plus or minus 1, that's where you want to be. If you're too hot, your body needs to start doing things, pretty much a fever. If you're too cold, your body needs to do other things to warm you up, right? kind of things that we've been mentioning this entire course. It's one of those hot words that you hear in almost every single chapter, because at the end of the day, that's what your body's doing, maintaining homeostasis. So I'm just going to read through some of this, and then I'll get through a little bit more examples of what I consider to be homeostasis. Okay, so an example, a certain item in the blood decreases. So an area of the brain will sense that decrease. So part of the brain is going to recognize that. A hormone will then be released. This hormone will stimulate the release of yet another hormone, this cascade effect that we like to say. This other hormone will stimulate the release of the hormone, which was sensed to be decreased in the first place, causing it to be increased to a desired level. And this is a very specific example involving the thyroid hormone thyroxine. Again, do we need to know the specifics of every single hormone and the loops? No, that's something that you may learn in medical school if you go in that direction. But for now, just understanding the general information, more generic about how this stuff works, is better for me. Okay, before we move on too far, actually, we'll do it with calcitonin, so we'll keep scrolling down for now. Let's talk a little bit about thyroxine. So thyroxine, if we scroll back up, you can see where we had it here. T4, right? Thyroxine. That's just a nickname that we often have for it, but thyroxine is perfectly fine. This is one of the major hormones of the thyroid. Its primary purpose is going to be involved with basal metabolic rate. Let's see if I can highlight a little bit here. Actually, I'll just... basal metabolic rate, aka your metabolism. So, the rate at which the body uses oxygen to transform nutrients into energy. You have likely heard of metabolism many times before, especially when it comes down to people claiming, I have a slow metabolism, I have a fast metabolism. People that have a fast metabolism, oftentimes, here we'll blow this up a little bit. See. Nope. That's not what we wanted. Okay, either way. People that have a fast metabolism, there we go. People that have a fast metabolism often will claim, oh, I can eat whatever I want, fast food every day if I wanted to, and I don't gain a pound. Well, it's something like that. Does that necessarily mean they're eating healthy? Definitely not. We'll learn more about that in digestive system. But that is something as to how your body just burns energy. Whereas people with a slow metabolism, and this can happen definitely when you're younger, and your metabolic rate slows down as you age anyway. But for me, for instance, I never had that fortune of being in high school or middle school, even going through puberty and having the ability to say, I can eat whatever I want. It never was that way because my family overall just has a slower metabolic rate. So people with a slower metabolic rate have to be a little bit more concerned with what they're eating. If you eat too much fast food, for instance, or unhealthy foods, and the amount that you're exercising or your levels of calories that you're burning a day, it's simple math, right? Too much in, not enough out, you start to gain weight. So those of us with a slower metabolic rate are very familiar with all this. But the long story short, it's basically how you effectively and efficiently burn energy. And if we remember way back in quarter one when we did our macromolecules unit, energy is just carbs, fats, or protein. We always love our carbs. That's always number one. Then you're going to use fats if you don't have any carbs left. And then as a last resort, protein. So as far as some target cells that can be directly affected by thyroxine, it can affect other things besides just metabolism. So for instance, protein synthesis is very important. Bone growth, neuronal maturation, so the neurons, how they mature, obviously important. And cell differentiation. That sounds very complicated, but if you remember, we talked about this magical cell called a stem cell. I like to think of it like Ditto from Pokemon, for those of us that played. These cells are able to differentiate and be told via special coding, hey, from now on, you're going to be a muscle cell or a bone cell or a thyroid cell. So thyroxine helps with that differentiation process. All right. Now we're getting into what I wanted to talk a little bit more about, the effects of calcitonin. So as far as calcitonin is concerned, as you can tell, based off the prefix alone, it's associated to calcium, right? It is associated with phosphorus as well, but calcium is really the big thing we're going to be focusing on. It is secreted from the thyroid, specifically the parafollicular cells, when blood calcium levels are high. So when your calcium levels are at a high level, you're going to secrete calcitonin. So what's the point of calcitonin? I'm going to go ahead and just put this right here. Calcitonin lowers calcium levels, and then you see that plus plus is because in chemistry, again, for those of us that have taken chemistry, calcium has a positive 2 charge when it's at rest. That's just extra information. Calcitonin lowers calcium levels by slowing the calcium releasing activity of osteoclasts. Hey, we've seen that before, right? Remember osteoblasts and osteoclasts? Blasts build bone, clasts consume bone in the bone, and increasing calcium secretion by the kidney. So another way to summarize this is that when your blood calcium levels, so when you have too much calcium in your blood, your brain detects that. Your brain tells the thyroid, start secreting calcitonin now. We need to decrease our levels of calcium. Because if your calcium levels are too high, that can cause problems. Literally, anything that is too high or too low in your body puts your body out of homeostasis. So this is the physiological process of how this works. It tells the osteoclast, hey, slow down a little bit. You don't need to eat as much bone right now. Because when they consume that bone and the bone tissue gets degraded, what's released is more calcium. And it actually increases calcium secretion. So you actually the kidney can absorb that calcium. So it tells both 2 different parts of the body, hey, we need to start fixing this. On a day-to-day basis, this hormone is secreted constantly, especially, for instance, when you consume something high in calcium, which is not just milk. That's something we're going to learn a lot more about in the digestive system. The whole milk thing is a bit of a marketing ploy, if you want to call it that. But a lot of foods we consume have calcium. We need calcium for many aspects of our body, including our bones. So throughout the day, whenever you have these spikes in calcium, you're going to have moments where you need to decrease it back to normal. That's to be expected. Now, here's something interesting. You see here, it acts mostly during childhood. So why that's a big deal? Childhood, especially, infancy, and then eventually toddlerhood, and then eventually, childhood and into prepubescence and pubescence, those are the moments of your life that you're undergoing the most amount of physical growth that you will ever go through. That's not to say like necessarily fat gain or muscle gain or vice versa. This is just pure growth. So during this time period, it makes sense that calcitonin is kind of going on high alert because you're growing constantly. Your calcium levels are going to be high by default. So during this time period, we're definitely going to see higher levels of calcium is what we're expecting to notice. All right. Let me see if I can find a blank. Let's actually look it up here. So we're going to search calcium negative feedback loop. All right, this is a pretty good picture here coming up, just to show us how this whole process works. No, it's way too small. Okay, this is a little bit better. All right, I'll go ahead and hide that. All right, so I'll start off the next video kind of going into this a little bit more in detail. But what we observe here, we have our body at homeostasis, aka everything's normal, nothing wrong, right? Well, when your calcium levels go high, right, your brain notices something's wrong. The brain tells the thyroid, secrete this special hormone, calcitonin. The purpose of that is to decrease your calcium levels so that you're back to homeostasis. Sounds good. However, there's also the opposite that could happen. Now, near the thyroid, we have these tiny raisin-shaped glands on the backside of the thyroid called the parathyroid, and we'll talk more about that in our following video. But in this situation, when calcium levels fall below, so when the calcium blood levels are too low, the parathyroid is actually going to secrete a hormone called PTH, parathyroid hormone. The whole job of parathyroid hormone is to raise calcium levels. So this is a classic example of negative feedback. The idea here is that when your body's out of homeostasis, you either secrete a hormone to increase stuff or you secrete a hormone to decrease stuff. That's kind of the gist of how this whole process works. So let's just jump back to here. Okay. So again, the idea is that you're increasing or decreasing based off of what is needed for the body. In this case, with calcium, too much calcium in the body, you're going to secrete calcitonin. Not enough calcium in the body, you're going to secrete this other hormone that we'll get more into in just a bit called parathyroid hormone. So the final thing to discuss about today, the parathyroid glands. As I mentioned, they're raisin shaped, very, very tiny, found behind the thyroid. So you would never see them. You would have to physically cut the thyroid out in order to see it on the backside. But we have roughly 4 of them. Sometimes people have less than 4. This is a pretty good estimate, though. As you can tell, they're usually embedded. So they're usually built into the actual thyroid. It secretes its own hormones, too. But that's something we'll get into in our next video. All right, thanks for watching.